we are going to have a discussion on spectroscopy questions.
So for the complex in non-fluxional state, for the complex in the non-fluxional state, the expected 31p proton decoupled NMR signals, yeah, resonances are, okay, you know the I value of phosphorus already. All right, this complex, how many? One singlet, one doublet, two singlets, two doublets. All right, what is the correct answer? Now, first of all, what do we have? We have iridium. Iridium के बारे में कुछ mention नहीं है. It is not mentioned about iridium, so we'll just take it. It is not active, right? And the complex in the non-fluxional state, it is a trigonal bipyramidal system, and we think कि ये fluxionality कर सकता है equatorial action, but it is mentioning non-fluxional, so it is going to be as it is, नहीं change होगा. So expected phosphorus resonances. How many phosphorus resonance? This is axial, this is equatorial. तो ये जो axial वाला phosphorus है, this is going to be split into two by the equatorial one, and the equatorial one is split by into two by the axial one. That's it. So you're getting two doublets only. Very easy. ये देखो ऑप्शन नंबर ए है, ये क्वेश्चन रीड करो. This is important, right? That's why I've taken this question. ये बहुत लोग गलती करते हैं. So as I mentioned, guys, that the ortho and the para position, these are more de-shielded as compared to the meta one. So C2 is going to be more de-shielded as compared to C4, which is going to be less more de-shielded as compared to C3. This is the order of de-shielding in pyridine. ठीक है? So that is why C2 की value सबसे ज़्यादा होगी 150, which is greater than 136 for C4, which is greater than 124 for C3. So definitely this is the correct answer. Awesome. Let's move onwards. Question number 3. So the next question is, which one of the following exhibits 5 signals in broadband decoupled C13 NMR? Yes. Now this one definitely has no symmetry, तो ये 5 तो नहीं हो सकता. This is going to be greater than 5. We are absolutely sure about this. So this is wrong. Next one, we have a sigma plane like this, and we also have a sigma plane like this. So 1 and 2 and 3, only 3 resonances. Then in this one, we have a C2 axis from this point. ये इस point के ऊपर एक C2 axis है. You can rotate. So these two carbons will be same. These two will be same. These two will be same. These two will be same. तो कितने हो गए? 1, 2, 3, 4 and 5. All right. अच्छा एक second. 5 कहाँ से हो गया? This is 1. If I rotate this, 1 and 5 are same. So this is 1 only. This is 2 and this is same, 3 and 3 same, 4 and 4 is same, right? You are having 4 signals in this one. फिर D में आते हैं. There is a sigma plane of symmetry over here. So 1, 2, 3, 4 and 5. D is the correct answer. All right, like this. Chalo, move onwards. Vicinal coupling constant J expected for the protons H, P and HQ will be in the range. Will be in the range dash for this molecule. This is HQ. This is HP. ऐसा ही तो है. And you know what? The trans hydrogens do a better coupling as compared to cis. So if just in case there is a question that there is a cis decalin system like this, what about the coupling constant of the cis decalin system and the trans decalin system? You know this that coupling के लिए orbital का interaction जरूरी है. So the orbital interaction is either best when you are having sin 0 degree or trans. मतलब either 0 degree or plus minus 180 degree. This is the best angle according to the Kepler's curve for the coupling. So C is the correct answer. Yes, for this one C is the correct answer. इसके लिए पूछेंगे तो we will have lesser value as compared to this. Okay, got it? आगे चलते हैं guys. Now you have to match. एक match the following वाला question करते हैं. ठीक है? So this is our list 1 and list 2. The molecule A looks like this. Br, Cl और ये दोनों hydrogen है इधर. And option 1 I'm writing approximately 1 hertz. This is 1 hertz I'm writing, okay? Is 10 hertz approximately. Option number C is approximately 15 hertz. Now which of the following is the correct? Option number A. चलो देखते हैं. So first of all, this is a cis alkene. So these two hydrogens are going to do a coupling which is very less, but how less? 10 hertz. ये जो vicinal वाला होता है, this is very less. This is going to be 1 hertz. And the trans is the best. 15 hertz. So A matches with 2, B matches with 3, C matches with 1. B is the correct answer. Yes. Next question. In the proton decoupled, 13C and 31P NMR spectrum of CH3 whole thrice P double bond O is. ठीक है, आपको क्या फाइंड करना है? नंबर ऑफ लाइंस. 2 and 1, 1 and 2, 3 and 1, 2 and 2. So you are having only one phosphorus present and all the methyls are the same only, isn't it? सारे methyl तो same ही लग रहे हैं. Then what is the correct answer? No, why the phosphorus is 2? Why the phosphorus is 2? For phosphorus. Okay. Because phosphorus will not be split by the carbon. क्योंकि कार्बन यहाँ पे वैसे भी हम inactive मानते हैं, not carbon to be able to split somebody else. That we say it is inactive, or let's say very dilute nuclei, right? So for phosphorus, you are going to get only one signal, which is correct. For carbon, how many signals are going to be? Carbon भी तो सारे same है. All of these methyls are going to be the same, it looks like. So one signal for the carbon also. And since it is, you know, you are not having any proton, but when we are checking the C13 value, when we are checking the C13 signal, then the carbon is active only because we are looking for active carbons. Then the carbon is going to be split by the phosphorus, isn't it? Split into a doublet by phosphorus. So 2 and 1 is the correct answer. The correct pair of one hydrogen and proton and 31p NMR spectral patterns for CHF PCl2 whole 2 is, how is it going to be? The correct pair of proton NMR and 31p NMR spectral patterns for this compound CHF PCl2 like this. Now the question is, you are only being asked for the signals of proton NMR and 31p NMR. So there is only one proton. That's why you're going to get only one signal for this. Okay. So one signal, how is it going to split? That one signal is going to split into a doublet by fluorine. Fluorine will split this into a doublet. And then it is going to be split into a triplet by the phosphorus. There are two phosphorus, so 2Ni plus 1 करके ये हो गया ऐसे. What are you getting? You are getting two triplets for the proton NMR. You are getting two triplets, guys. एक A नहीं हो सकता. You are getting only one triplet over here. But here you will be getting a doublet of a triplet. Like this in option C. Okay. Then we move onwards to 31p. How many are there? There are two different molecule, two different, but we actually have a sigma plane passing through. So ठीक है, एक ही मानेंगे because these are sigma plane reflectable. So these are enantiotopic groups. So they'll give you one signal only for the 31p NMR. That is going to be split into a doublet. First by, let's say first by fluorine because the coupling constant is high. Then again into a doublet by the hydrogen. So what are you getting? You are getting two doublets of equal intensity like this. So C is the correct answer. ऐसे question अब आने लग गए हैं ना? In the GATE, in the CSIR NET, all the examination, you might expect a question like this. Okay. Next question, question number 8. ये देखो. चलो. So when the temperature is very very high, तब वो सारे same हो जाएंगे, isn't it? What is the structure of DMF? This is DMF. ठीक है? So when the temperature is too high, 150 degrees centigrade, then both of the methyls are going to undergo, see this is how the nitrogen is going to undergo rotation. Low temperature पे क्या होता है? Low temperature पे you are also going to see a lot of resonances like this. And because of this resonance, one methyl and the other methyl have become diastereotopic to each other. ठीक है, इसी वजह से क्या होगा? They will show different values at low temperature. Let's say A matches with X. ठीक है. Then one sharp singlet for 6 hydrogen when I've increased the temperature to 120 degrees centigrade, and one broad signal for 6 hydrogen. ये क्या है? AXBZCY. हाँ, sorry, I just missed out the sharp and the broad. Yes, the sharp and the broad one. See, at a very high temperature, it is going to be a defined value. No, the answer is B only because A sharp singlet will only happen when the temperature is nice and very high so that it is constantly rotating, it is not stopping. तो ये आपको clearly बताएगा that both of the methyls have become same at very high temperature. And when you are getting a broad singlet like this, broad matlab ki that it is in the process of becoming free and there is some resonating portion also. So जो broad signal है ये थोड़ा सा unclear signal है. This is an unclear signal. That is why it is going to be at a 120 degree centigrade and the sharp value is going to be at this. Okay, तो ये correct answer है option number B. Got it? Okay, चलो next question. So the answer is option number A only, and this is a Beckman rearrangement. See, we don't have to try to draw the structure of this, not necessary. हम क्या करेंगे ना, we will just decode the answer from the options only. ठीक है? So 9.89 singlet 1 hydrogen, ये किसके लिए है? This is for the NH proton. 7.8 singlet 1 hydrogen, this is let me check the data once. हाँ, ये बेंजीन के लिए है. Singlet means there is no meta coupling which is mentioned, तो ये वाला हो गया. Right, then there is 7.45. These are all benzene protons, but these are going to be different. This is a multiplet, this is a singlet, and these are going to be doublet. ठीक है, तो multiplet वाला कौन है? 7.17 is a multiplet. 7.45 is 7.12. This is 7.45. These are all benzene protons. Or 2.063 hydrogen. This one. Okay. So this has formed after the rearrangement. Ortho not possible. Only meta is possible. But ये सही answer नहीं है. Because this is the bromoacetophenone. This is coming from C. It is like this. Bromoacetophenone. तो अब ये क्या करेगा? In the presence of acid, this is going to go away and this is going to shift. So ultimately what happens? You are going to get this molecule. Nitrogen से connected है and there is a positive charge on this carbon. So water is going to attack over here and release this electron density after the OH has attacked. तो finally ये वाला molecule बन जाएगा option number A. Yes, yes Ashika, absolutely. So A is the correct answer. ठीक है? आगे चलते हैं question number 10. By the way, this is a TIFR question. All right. So it is the same question again that we have done previously. Which of the following most closely resembles the 13 NMR of ethanol when the hydrogen and carbon coupling is higher than a carbon-carbon coupling? Just that. Only that you have to understand. Ethanol का बताना है. How ethanol is going to look like. Don't look at the next question till now. Chalo, let's discuss. Now, see what is happening. Which of the following most closely resembles the C13 NMR of ethanol? So, ethanol is a structure CH3, CH2, OH. Now, the only thing is that there is a carbon-carbon coupling also. Otherwise, if we only consider the hydrogen coupling, then This carbon is going to be a quartet because of this hydrogen. This carbon is going to be a triplet because of these hydrogens. Now the quartet and triplet are further going to be divided into a doublet and doublet because of the carbon. क्योंकि carbon carbon की coupling हो रही है ना, carbon A and carbon B. So carbon A has a signal like this, a doublet because of carbon B, and then it is going to be split. Sorry. One more thing you have to take care of over here according to the question, that while we are doing a splitting tree diagram, we have to first consider कि किसकी coupling ज़्यादा है. This has a higher coupling constant. So first you are going to split by the hydrogen. ठीक है? So carbon A is going to be split by a hydrogen in 1331 like this. Then into a doublet. All of these are going to be a doublet by the carbon B. How does it appear? It appears as a peak like this. 1, देखो ये हो जाएगा 1:3:3:1. This 1, 3, 3, 1. Now this is 1:1:1 ऐसे हो जाएगा. So again 1, 1, 3, 3, 1, 1 like this. 1, 1, 3, 3, 3, 3, 1, 1. So this portion is correct for the methyl. But on a scale from 0 to whatever 10, 12, 13 whatever, ऐसा उल्टा जाता है ना scale. ठीक है? Yes. So on a scale of 0 to 10, which is more de-shielded, a CH2 or a CH3? That also you have to understand, no? और ये CH2 कैसा होगा? CH2 is going to be giving you 1 1 2 2 1 1, this kind of a signal. But on a scale of 0 to 10, who is more de-shielded, CH2 or CH3? That is going to come on the closer side to this. ये देखो ये CH2, CH3, 0 to 10 scale. So answer is option number A. Right, correct. A is the correct answer. Got it? चलो next question we are going to do. ये TIFR का question है. Now B, C we are going to write over here. CH3, CH2. All right, A is correct. क्योंकि यहाँ देखो, you need a multiplet, isn't it, at the center? So this hydrogen, this one, this is going to be split by 6 hydrogens. 2ni plus 1 में आएगा 2 into 6 hydrogen into half plus 1, that is going to give you 7. So these small lines are nothing but a septet. So this hydrogen is going to be a septet, and it is going to split. It is going to split these two methyls into a doublet. So we are having this doublet, the longer doublet for 6 hydrogens, and this is also less de-shielded. 0 to 10 का ये scale है. This is less de-shielded. But this CH2, which is again going to be a doublet, is more de-shielded because it is connected to the heteroatom. So this is the CH2X wala CH2. Okay, very nice. Very nice. Now let's do one more awesome question. Question number 12. ये देखो. So an organic compound has the following spectroscopic data. Let's see. First thing, चलो प्रोटॉन एंड हमारी देखते हैं. 1.4 and 3.9 ppm, both are singlet, intensity 3:2. So if the intensity is 3:2, it could be 6:4 also. All right, the ratio is given. We are not having the exact protons. ठीक है. Now look at option number A. There are methyls and there are CH2s. Okay, methyl is given to be 1.4. This is given to be 1.4 and this one is given to be 3.9, which is exactly suits the question. Here also you will say, ma'am, here also it suits the question ki हाँ, the 3.9 value is given. But this is not for the methyl. This is for CH2. If you understand, this is for CH2, okay? And 1.4 is for the methyl, not for CH2. ये तो वैसे unsymmetric, both B and C are both unsymmetric. They will give you a lot of protons. The answer could be A or D. And in D, it is just the reverse of what we are looking for. Now, strong absorptions in 1000 to 1300 ये है carbon oxygen stretching bands of the ether. ठीक है? C13 NMR 108, 64 and 25. So these are going to be 64. This is going to be 108 and these are going to be 25. How nice. Then we have mass value 102 very small, 87 and 43. How can we do the fragmentation? ये क्या है? Acetal है ना? This is acetal only. How can we push this away? O minus, it is going to be like this. All right, guys. So आज के लिए हमने काफी question practice कर लिए हैं. All of these questions are really interesting questions. Have a nice day. I'll see you all soon.